All right, we're back. We're still on page 7 of notes 9 of Calc C, and we are writing series for things that maybe it doesn't look like you could initially write a series, and we're finding ways. So sometimes you take a derivative, sometimes you take an antiderivative. This one, to me, looks like we're going to do two things and see if it works. So first thing that I'm going to do is I'm going to rewrite this thing as x squared times 1 over the quantity 1 minus 2x squared. Now, the reason I'm doing that is that I'm going to focus in on this thing, and I'm going to try to write a series for this. And then once I'm done writing a series for that, I'll just multiply by x squared, and like that's going to work. Every term of that series multiplied by x squared, that should work. The issue is, how do I write a series for this? Well, if you just did the previous problem over here, you probably have some idea that maybe we should find the integral of that. So let's see if we can do that. So we're going to find the integral of, let's make it 1 minus 2x to the negative 2 dx. It's probably, you run into this, so I always think it's weird. When you get to Calc 2, it's like you stop doing a lot of the things that you feel like are calculus, right? Like, we're not taking a lot of derivatives, we're not taking a lot of integrals, even though that's like all you do in Calc AB, Calc 1. When you hit series, it's like all of a sudden you hit pause on that for a while. The most you seem to be doing is using the power rule, reversing the power rule. So it gets, you get a little out of practice, and try not to, because it comes back with like sort of a vengeance when you do some more advanced techniques of integration, but like, whatever. So there should have been a 2, a 1/2, so this is going to be negative 1/2 times 1 over 1 minus 2x, I think. So if I took the derivative of this, right, so that's like 1 minus 2x to the negative 1, so negative 1 comes down, and then you get a negative 2, oh, a negative 2 by the chain rule. 2 negative, so there should have been a negative 2, a negative 1/2, and then the, I think it's positive. I think it's positive 1/2. So if I took the derivative of that, you bring down a negative, then another negative 2, those cancel, that thing to the negative second. Pretty sure. Okay, so this we can do. This looks like something, this looks geometric to me. Oh, plus c, sorry, all you people out there. Plus c. It's just going to go away though, so it doesn't matter, but whatever. N equals 0 to infinity of, let's say, 2 to the n, x to the n, plus c. I should put it on the outside. This is why you put c first when there's a summation, because now it's confusing. Like, are we summing up c to infinity, which obviously would diverge, but no, it's on the outside. What's my interval? So the absolute value of 2x less than 1, so this will be the absolute value of x less than 1/2. Okay, so we have this. And then that's for the integral. So I'm going to take the derivative, right? So the derivative of the integral is, okay, the derivative, so d dx of this thing, I'm going to copy and paste. The derivative of this thing should be equal to the derivative of this other thing, which I'm also going to copy and paste, or duplicate, which, as you probably know, is my favorite. I think that's so cool. Just like do it and you move it around. Like, seems there. Okay, so now the question is, so negative 2 comes down, a negative 2. What the? Oh my God, what am I even doing? Sorry, I was literally trying to take the derivative of this, and I was like, nothing matches, but like, let's forget that happened. So this 1 over 1 minus 2x squared is, all right, the derivative of this thing, definitely 1/2. So it starts with a constant, so now we got to move it to 1. So n equals 1, 2 to the n, x to the n minus 1. Derivative of constant is 0, so that's gone. So we have this, which maybe I'll rewrite a little bit. I think I made like kind of a big deal of that in the last video and then just stopped talking about it. Oh, that's fancy. N minus 1s. Now, interval. we got to test the endpoints, right? So the open interval is definitely -1, or definitely -1/2 to 1/2, because the integral and the derivative have the same open interval of convergence. It just can vary at the endpoints. So if I let x equal -1/2, it's going to diverge no matter what, right? Because when I put in 1/2 here, I just get 1 to the n-1, but that's just 1. You add those up, definitely diverges. If I plug in -1/2, I end up with -1 to the n-1, which just keeps going -1, +1, -1, +1. That's one of the series that initially like got people interested in infinite series, because like, what's happening? Like, is it like 1, -1, +1, -1? So like, do you group them consecutively and you just go 0, 0, 0, 0, or you do like keep the first one and then you do -1 + 1 is 0, -1 + 1 is 0, and keep throwing them out so you get 1? Like, what's happening there? So I'm going to say that this is definitely, whoops, only, okay, why are we working over at the edge when we have like all this space? I'm going to say this is just the absolute value of x is less than 1/2. And I'll say like, let x equal ±1/2. Then you get, this is terrible. I do not like this. What do we get? Plus, you get like ±1/2, ±1 to the n-1. This is garbage work. I would not be happy if someone gave me this work, but this diverges. So this is bad work. Let me like make that really clear. It's bad work. Don't do this kind of work. Nobody wants to see it. All right, so now we have that series, and now don't forget this. Got to multiply by x squared. So x squared times 1 over the quantity 1 minus 2x squared is going to be x squared times this summation, 2 to the n-1, x to the n-1. Where'd my n go? Oh, I just forgot it. Ooh, and so that doesn't, okay, so that doesn't really change anything. That there should have been an n here. There should be an n here. We can save this, potentially. There, I'm gonna squeeze it in by moving things. Okay, perfect. It's exactly what you were thinking it would be, except I forgot it here. Magic of fixing things on an iPad. Absolute value of x less than 1/2. So then x squared over the quantity 1 minus 2x squared is this one. Ooh, this one we could probably check. I'm saying we could probably check this one because I am not 100% confident on my work. Well, like, better to be underconfident than overconfident, probably. So I'm going to check this. How shall we check this? Let's see. Have the calculator spit out some terms, maybe? F of x is x squared over the quantity 1 minus 2x. And then it's like, you know, people see this process and they're always intimidated by it because it's like, how would I ever think to do all these things? Well, I just showed you, right? Like, and that's how I learned. Somebody was like, hey, look at this, watch what I do. And I watched and I was like, I guess I could potentially do that. And you'll be the same. Like, you eventually can do it. Let's get 5 terms. Let's get 5 terms. All right, now let's see what our summation spits out. N from 1 to, so I only need to go to 4 if I'm going to go up to the 5th, which that doesn't really make any sense. 1, 2, 3, 4. To go to the 5th power, 0 should be in here. 0? No, nope. No, I don't know. I don't know what I'm doing. I'm just going to go for it. 2 to the n minus 1 times n times x to the n plus 1. That takes me from x squared up to x to the, oh, x squared up to x to the 5th. Ugh. 4, 12, 32. Yes, it matches. So I'm going to say that was a pretty good job. I also think, I don't know, it's like so many videos for this one page, but you know what, no, I'm gonna plow through this next example, just blow through it. You know that that's probably not true, but I'm gonna try. So as to not have like a million videos for one page, because that just seems ridiculous. This is like what we just did, right? Well, first of all, can I just replace every x up here with x squared and just do a composition? That'll give me x to the 2n plus 2. X to the 2n plus 2, all of this stuff. I feel like that would work. What I'm going to do, though, is I'm going to do the work. So I'm going to say that f prime of x, so we're going fast. 1 plus x squared, which means I'm probably going to make mistakes, right? 2x, negative 1 to the n, x to the 2n, 0 to infinity, absolute value of x less than 1. Okay, so that's the derivative. And then, so I'm going to rewrite that because I need to integrate, and like, what in the world is happening if we don't distribute? So this is times 2 times x to the 2n plus 1. Oh, look at what's happening. Now, what's this 2? I don't know. Like, the other one doesn't have a 2. Is that a problem? Maybe. All right, so this is the, okay, so f of x is going to be c plus the integral of this thing, which will duplicate, and then dx. So that's, here we go, f of x is c plus integral 0, negative 1 to the n times 2, x to the 2n plus 2 over 2n plus 2. So I need c, but f of 0 is 0 as usual. F of 0 is 0. Did I mess that up? Nope. I thought I messed that up on a previous one. I didn't, because we didn't really need it. F of 0 is 0. So f of x is duplicate, is this. It's like off by a 2, maybe? And is that disconcerting? Oh no, but then it's 2n plus 2 there. 2, oh my god, 2n plus 2 and 2. Woo! Okay, let's check. Let's simplify that. That was ridiculous. I don't know. I feel like if I prove anything in making these videos, it's that I don't do the problems ahead of time. Which, like, I think that makes it more authentic, you know? If I plug in 1, I get negative 1 to the n plus 1. So if I, like, let's say, let x equal negative 1, we get negative 1 to the n over n plus 1, which converges by alternating series test, of course. And then if x equals positive 1, we get, wait, if x equals negative 1, oh yeah, because 2n plus 2 is always even. So that worked, even though I was thinking I was plugging in positive 1 the entire time. So that worked out really conveniently for me. Converges by AST. So then we have the absolute, so you can do the absolute value is less than or equal to, or you can do this. There you go. So both of those converge. That's interesting. I feel like on some level both of those should diverge, but like it's not the case. So like, what's the fundamental difference here? Like, this didn't converge at negative 1 because it was 2n plus 1. It was, yeah, it definitely didn't. That's so interesting. They're so similar, but like just a little different. I'm gonna just check. I don't know, graphically, I think. So I'm gonna graph the natural log of 1 plus x squared. Okay, that's a neat looking function. And then I'm gonna graph the couple terms like n 0 to, let's go to 50. of -1 to the n. Remember how surprised I was when there was an extra 2 and then a 2n plus 2 in the denominator? That was fun. Boom. Look at that. Super good between -1 and 1. Menu for, let's go -1 minus 0.1 and then 1 plus 0.1. Yeah, really good. And then if, let me trace menu 5 and trace to 1. And so we get, yeah, super close. And trace to -1. I would, yeah, you can like see the convergence there, I think. All right, so this is like, I don't know, is this a bigger topic or a smaller topic? Is it a bigger deal or a smaller deal that I make of it? I don't know, it's just great practice. Like there's so many good things in here. So that's the end of this, and that's exciting because we're done with these notes, and I will be back in the next video to talk about the next set of notes. So I will see you there.